In this video, I'm going to be talking about lambda expression, capture list in the lambda expression, and some tips and tricks using lambda expression. Let me use this space to explain the topics. First, let me talk lambda expression. What is a lambda expression? Right. This is a very simplified lightweight version of the function. Right. More specifically, this is a very simplified version of function object. Right, this is a kind of function object. It behaves like a function object, but it has limitations, but advantage and limitation both. Advantage in the sense that you can use this very flexibly. This is very flexible to use. You can create an instance when you want to use it. Just create at the point of using it and use it. You don't have to elaborated process procedure to follow to create lambda expression. So simplified, but if you have some things that are simplified, then obviously it's going to be it doesn't have that much power as the function object, like maintaining the state and those things. So very useful, and it has been extensively used these days in C++, particularly standard template library algorithms. So very important concept to understand, to know how to create, how to use it, and how to make it syntactically and logically correct. So let's do it. Lambda expression, I want to do inside for here. First, syntax. Expression begins with two square brackets and followed by parenthesis by something called trailing return type, right? So something like this. You have arrow followed by return type and body of the function within this curly braces. But one thing you should always note is, if you are putting this expression in a statement, then you should have semicolon. Right, you must have semicolon. If you are actually creating the lambda expression and using at the point of creation, you may not need a semicolon, but if you are actually creating lambda expression, giving it a name, and you want to use afterwards, then you must have semicolon. Also, how to do that? Okay, and this bracket thing is called something called capture list. It includes the list of the things that you want to capture to be used by the lambda expression. This is called parameter list, like the list of parameters in the regular function, because this is a function expression which should be able to receive the parameters, the arguments. So you want to have parameter list. And return type, this is optional. Compiler will actually infer the type. And you have body, which contains logic of the function. Right, these are the components of lambda expression. Let me first create a lambda expression. Let me begin with the sum function. Okay, a function to add two numbers. right? So you can have a lambda expression version of this function. If you want to create the lambda expression version of this function, then you want to start with two brackets, and for this parenthesis for parameter list. Inside in the list, you want to have the parameters same as the parameter of the function, and you have function logic. So this is the lambda expression, right? And if you want to give it in name, sometimes if you want to create the lambda expression and use for multiple times, then you need to give name. Name is not necessary for lambda expression, but you want to give name. My lamb is the name I have chosen to give it to it, and the type, if you know, it's not easy, or it's inconvenient to compute or evaluate the type manually of the expression all the time. So you want to let the compiler, C++ compiler, in for the type. So in this case, just go back to the semicolon thing I mentioned. So in this case, you are having name and you are equating this to the lambda expression. So this is entire statement. You need to have a semicolon at the end, right? This will make it lambda expression, and the name of this expression is my lamb. So with this, you are able to use this lambda expression. If I want to compute int a equals to 20, b equals to 21, then so I have this a equals to 20, b equals to 21. I want to call that lambda expression, right? The way you call is you use the name, and then use that as a function call operator. Name followed by the parenthesis with the arguments in it. So this is the way you call the lambda expression. If you know the name, or it's also possible that you can create the lambda expression at the point when you call. If you don't want to use the lambda expression for multiple times, you want to create to be used for only one time, then you don't need. It is recommended you don't have a name. You can create at the point you want to call, like this. So this is the lambda expression, and if you want to call this, you need to, because you can assume this entire thing as the function name, right? And if you want to call, you want to have the call operator here, function call operator, and you need to pass the values here, a, b. There is a semicolon missing in this system here. So this is the creation of the lambda expression and the invocation of the lambda expression, right? So let me show you the output of this code. Compile and run. Now you can see the output. This lambda expression actually resulted, it returned the output 41, summation of 20 and 21. In this case also it is 41, right? So you can create lambda expression like this. This is syntax, and this is captured list. So in the captured list, if you want the logic of the lambda expression to use the variables or objects in this scope, in the host scope, for this lambda expression, this scope is called host scope. The scope which actually encloses this lambda expression is called host scope. if you want to use things in the host scope, you can capture those things inside. For example, if I have if I want to compute weighted, for example, this A is the max percentage in one test, let's say 60%, and B is a percentage in another test, 80%. If you want to compute the weighted average of these two tests, you can have weight 1 equals to 0.2 for the midterm, W2 for one first test, weight 2 equals to 0.8 for the another test. So if you want to pass these max percentages as the parameter, but you also want to have access to the weight, so it is not always recommended or convenient. I forgot to switch to the code. Let me talk this again. So I think we were at this point, right? So this is the capture list. This list is to be used to capture the data from the host scope. We call this, for the lambda expression, the host scope is the scope in which the lambda expression is created. For example, if I have another function and if I create the lambda expression in this function like this, then this lambda expression is going to be within this host scope. So host scope for this lambda expression is going to be the scope of this function. Since we have created this lambda expression in the main function, so the host scope of this lambda expression is the scope of the main function, right? So let me erase this part. I don't need that. I actually use that just to explain host scope. If you want to capture things from the host scope, for example, if this is a percentage for midterm test percentage, final test percentage 60 and 80 percentage. If you want to compute the weighted average of midterm and final, if I want to compute the weighted average of this midterm and final, let me make change here, okay, so that this is now its value. So now you can see the parameter name in this lambda expression was A and B, and then you want to pass actually the argument you pass to the function invocation of the lambda expression is mid percentage and final percentage. So let me have I have two weight values, W1 20% and 80%. So I want to give the midterm percentage weight 20% and the final percentage weight 80%. I want to compute this as a weighted average. So if I want to do that, one option of doing is pass all the things and compute weighted average, and when you call the function you pass like this, right? When you have this lambda expression, it is I mean, sometimes it can get longer, so it is you can spread this into multiple lines. For example, this is a function body, put the body here, and this invocation. So it's I mean it is common practice to spread the lambda expression in multiple lines. So you pass, but this is not a recommended way because you cannot be passing all the things. So in this case it is very reasonable to treat weight as a different things, not as the parameters to be passed or the arguments to be passed. So in this case, if you want this lambda expression to be able to use this wn and w2, then you can capture this. You can capture wn and w2, and you can capture that by having those names in the capture list. So if I put these names here, it does capture wn and w2, and when I call, I don't want to pass this w1 w2 as a parameters. So this list will capture these values and allow those values to be used inside, and this is, you can treat this as a function, and then this is a function call invocation. Let me go to the output, compile and run this program. So you can see in the second case it was weighted average, so it is 76. In the first case we didn't have, it was just summation, so 60 plus 80 is 140. In the it was 0.2 times 60 plus 0.8 times 80. It's going to be 112 plus, it's 12 plus 64 is 76. Okay, so this is how you can have a capture. You can capture this way, I mean the data in the host scope into the lambda expression. Let me separate this lambda expression from this cout statement so that it becomes clear to discuss and work with it. So this is the lambda expression. Now if I want to make changes to w1 and w2 inside the things that are captured, for example w1 if I want to do this, it will not allow me to do this, because if we capture like this, this is something called capture by value. Okay, when you in the capture list, you can capture by value, you can capture by reference, you can have combination of capture by value and reference. You can capture all by values. So you can have a different combination of captures. For example, if you want to capture w1 by reference, you capture by reference, you put this symbol before the name. In this case, w1 will be captured by reference, w2 will be captured by value. Then it allows to make changes. In this case, you are able to make changes to w1 only, not to w2, right? For example, if I display wn and w2 after I actually call the lambda expression, So with this, let me see the output of this code. So you can see wn and w2, initially it was 0.2 w1, it is changed to 1.2. so it has changed. So the change that was made within lambda expression actually it reflects in the value that was captured, the variable that was captured itself, right? And if you want to, if I have, let's say, 10, 20, 100 different variable, then it's possible that I can capture everything by value by having this equal sign within this square brackets. It will capture all by values, w1 and w2 by values. It will also capture this percentage. So if you capture everything, then it's also possible that you don't have this a and b. You can just have the entire expression like this here. In this case, it would be w1 times plus w2. You can also use the expression like this in this case, right? So but if you want to capture one variable by reference but everything else by value, then you can have again comma, capture x1 by reference and everything else by w1 by reference and everything else by value. So I think you should do this. Yeah. So first you capture everything by value, then make an exception to that particular variable. So w1, capture w1 by reference and everything else by value. Or it's also possible that you can capture everything by reference and capture w2 by value, right? So in this case everything else will be captured by reference and only w2 will be captured by value, right? So this there are different ways of capturing. There are different combinations, so make sure that you practice all these things. Okay, one more thing I want to explain here is you can also pass this lambda expression into the function using function pointer, right? If I want to display the weighted average, not in this space but within the function, in this function, then I should be able to pass no, it's a bit complicated to pass the capture this value, so I'm not going to do weighted average. You need to pass all these things. You can do that. So first you need to pass the lambda expression, I mean the function point. You need to have function pointer to accept this lambda expression. So return type of this lambda expression is obviously, you can guess, it is in this case is double type, because the result of evaluation is going to be double. So let me have double type here. So double function pointer, and it receives two variables, int a, int b. And we can also pass the weight. So, and you need to pass all those things, all this midterm percentage and MP int final percentage, and you can call that, for example, if I have this sort of thing, we need to have a little bit different way of displaying it. So I didn't want to capture anything here, and receive everything by 1. So if I already have this function pointer, I can use, I don't need to have this create the expression. Use a function pointer, and then pass these things. It's going to be MP, FP, W1, and W2. So in this case, you don't need the name of this. This is just a declaration, so you don't need the name of the parameters. So we have this thing here. If you want to call this function display weighted average, then I can call here from this place. Let me make a simple correction. It should be average. So here I want to create a lambda expression. First parameter is going to be lambda expression that is passed, and the second is midterm percentage and final percentage, weight 1, 2, right? Int A, int B, double W1, W2, return A times W1 times A plus W2 times B. So this is the lambda expression you pass as the first argument. It will go into this pointer, and the values you pass is midterm percentage, final percentage, and W1 and W2. So let me see the output of the execution of this function. Compile and run. Now execute. So 136 is displayed. I think that is correct value which was displayed before in the previous case as well. Yeah, here. So yeah, this is the way you can pass lambda expression into another function. Now we have discussed lambda expression. I also discussed capture list in detail. Now some tips and tricks. When you use lambda expression, you need to know some of the things that you may not need to perform, to do. Right? Let me simplify this thing to explain it better. So I'm going to remove this thing as well. Right? Let me also remove this thing here and remove the capture list. Now if this double is this these things are constant, then you don't need to constant double it shouldn't require you to capture this. So let me run this, switch to the compiler. So it's a problem. Let me also remove this thing. I don't need this stuff. So if I have a constant integer x equals to 10, y equals to 20. If I have constant and static variables, then I don't need to capture these things, x plus y. I can use those variables without capturing. So just remember, constant and static variables and the variables in the global scope. So I have a variable in the global scope. I can use that variable without capturing. That is the reason why I am able to use cout object inside lambda expression. I'm not capturing cout here, but I'm using because this comes from the global scope. So that's the reason why we're able to use cout object, and I'm able to use this the things that are in the global scope, and I'm able to use the constant and static type objects without capturing. Another tip you want to know about lambda expression is, if you are in confusion on whether to use the regular function or lambda expression, right? Always go for regular function if there's confusion, or if you don't have any confidence, any convincing reason for using lambda expression, go for regular function. So again, just to repeat what I discussed, global variables do not need capture. And another thing you want to keep in your mind is constant variables. Another thing you want to remember, memorize or keep in your mind is static variables. So another thing is in the class scope, if you are using the lambda expression in class, in class member functions, lambda expression must capture this pointer. Access the instance variable. So I'm going to I will demonstrate this, how to do this in the next exercise. So for this, to demonstrate this, let me remove everything and only keep this thing, right? I'm gonna demonstrate this, how it actually works, how to do that, right? So in the class scope, if you have a lambda expression used inside the member function of the class, then you must capture to use the instance variables. So first, let me suppose I have a class student, default constructor, so name, I think I should, let me move this inside the body of the function. So this is the default constructor, and I'm gonna have so this is the custom constructor, and I also want to have a function to print the data, and inside this function I want to have a lambda expression, and I want to use this lambda expression to display the data. Right, this is going to be my lambda expression, and I want to invoke this lambda expression here. Okay, so again, let me explain it. I have print function and lambda expression to display the data. This I actually want to use this lambda expression to display ID and name, but you know this is complaining that means this ID and name is not accessible in the lambda scope, in the scope of lambda expression. Therefore, if you want to be able to access this, then you need to capture this pointer, the current pointer to the current object. So you can capture this pointer. So now after this, access to ID and name becomes valid. So that is the actually point I was actually trying to make. In the class member functions, lambda expression must capture this pointer to be able to access the instance variables. So let me have an application of this code. Right, this is the code I'm gonna execute. again I need to have the library, I guess, C string. So now the data is displayed as expected, right? So yeah, just one more time. If you want to access this instance variables from within the member function of a class in the lambda expression, inside the lambda expression, then you must capture this pointer. Okay, this is the end of this discussion, lambda expression, capture list, and some tips and tricks. Thank you.